So example 2, we're asked to solve for theta. So we have the cosine value given to us. It's 4 over 7. Cosine goes with x. So we have a horizontal length of 4. Just highlight that. We have a horizontal length of 4 here. And we have the radius as 7. Now, because the quadrant is not specified, we have to consider both positions in quadrant 1 and quadrant 4 because it can go up and give us the blue dot, the blue position, or it can go down and give us the red position. Okay, so we have two positions that we have to consider. And in fact, our answer has to give us both theta 1 and theta 2. So we're going to use once we've drawn the solution here, we can see clearly that it's in quadrant 1 and quadrant 4. We can then find the solution to this, or the angle, using an inverse. Okay, so I'm going to do an inverse cosine of that ratio. And when I do the inverse cosine of that ratio, 4 over 7, it gives me a quadrant 1 angle of 55.15 degrees. Now that happens to be theta 1. That's the one that I've drawn in blue here. That's a quadrant 1 angle. There is also that quadrant 2 angle, the quadrant 4 angle, which we'll call theta 2. Now, theta 2 cannot be found from the calculator. We have to use the symmetry to get this. So theta 2, we could write it as negative 55.15 degrees. That's correct, but really we should use the positive angle. So to get the positive angle, we're going to do 360 minus 55.15 degrees, and we get the positive coterminal angle of 304.85 degrees. Now they are the same angle, negative 55.15 and 304.85, both locate the same position, so it's the same angle. In this next example, we have the point given as negative 2, negative 6, so that's a quadrant 4 position, quadrant 3 position, okay, and that we want to find the standard position angle theta. Now, because the quadrant is known, only one angle is correct. We only need to give one answer here. We don't need to draw two pictures because we know exactly where that position is. There's no ambiguity about what the position is. Unlike the previous question here, where we started with cosine, and cosine only tells us to go to the right. It doesn't tell us to go up or down. Here, we've been given the actual coordinates, so we've been asked to go left and down, so we know the exact quadrant. We still need to decide which angle we're going to use, theta 1 or theta 2. So we still need to undo the ratio. In this case here, I've solved for the hypotenuse, so I can use any of the ratios I want. Okay, so I have the horizontal cos, I have the vertical sine, I also have the slope. Okay, so I'm going to use just the tan ratio. So I'm going to do an inverse tan, and the slope is negative 6 over negative 2, or basically inverse tan of 3. And that gives me a slope value, an angle of 71.565, so I'm going to round that to 57 degrees. Now that angle is in the wrong quadrant. It is over here. That angle is our theta 1 angle. That's clearly the wrong position. Okay, so this is not the one we're looking for. We want the one that is 180 degrees to the other side of the circle. So really that's theta 2. And again, we don't find theta 2 from our calculator. We just take the original angle of 71.57 degrees, and we're going to add 180 degrees to that. We're going to go halfway around the circle, and that's going to give us 251.57 degrees. Okay, so we'll call that angle theta 2. That's the angle that we're looking for.